Hello students, welcome back. Now we are going to talk about step response of RC circuits. That means if I have one RC circuits, that means one resistor, one capacitor for sure, and there is a DC voltage source or a current source present in my circuit even after t equal to 0. So that means after t equal to 0, we are no more talking about a source free circuit. So it is going to have some effect from this source also. So that is called step response of RC circuits. So if I have a circuit like this, we can again write the KVL equation, and the KVL equation is this, and then we go ahead with our derivation, and finally we ended up at this. You can go through the derivation step, which is very easy, but let us focus on the outcome. Now if we look at this outcome, Vs is basically our source voltage and V0 was the initial voltage across the capacitor. So if we break down and make it easy, then we can say that this is the generic equation which we will get for a sourced or a DC response or a step response of RC circuit, and we can write it as V of t equal to V final, that means V infinity, plus V initial minus V final into e raised to power minus t by tau. So the voltage across capacitor will be summation of two things. That means forced response and transient. This is called forced response, the steady state response. That means when t is infinity, then what voltage will appear across my capacitor. And e raised to power minus t by tau, if you remember in source free circuit, what was my equation? V0 e raised to power minus t by tau. This is called our transient response, okay, or the natural response. So we are going from one value at t equal to 0 to some final value at t equal to infinity. In covering this distance, we are having this transient behavior. So what is this distance? What is this difference? That difference is V initial minus V final. So V initial minus V final, this is the journey. We are going ahead with this transient factor, that means with this tau. So now our focus is on finding only three things. One is V initial, one is V final, and one is tau. Earlier we used to calculate only V initial and tau. So now the only complication, or what is the addition, that we will find V infinity also. Now let us have a look at this question. We are saying this is the circuit. For t less than 0, my switch is here. For t greater than 0, the switch will go here. Now for t less than 0, these two are not part of my circuit. 4 kilo ohm and 30 volt, we are removing them. Now this circuit is in this state for a very long time. That means capacitor will act like open circuit. And whatever is the voltage across 5 kilo ohm, the voltage across capacitor will be same. So at t equal to 0 minus, the voltage across capacitor will be 5 by 8 of 24. 5 kilo ohm divided by total resistance into total voltage. So I got my initial voltage 5 by 8 of 24, that is 15. So this is our V initial. Now after t equal to 0, okay, the switch is moving to B. When switch is moving to B, that means this and this, they are removed from my circuit. So we are removing it. So now we are left with only 1 R, 1 C and 30 volt. Now look at only this circuit. In this circuit, if I go to infinity, then capacitor will again behave like open circuit. No current will be there in the 4 kilo ohm. That means all 30 volt will appear across this capacitor. That means V infinity will be 30 volt. So I got my second answer also. My first answer was V0. My second answer is V infinity. Now what is tau? Tau is RC. What is R? R is 4 kilo ohm. What is C? C is 0.5 millifarad. Multiply them, you got tau also. So you got tau, you got V infinity. So what is my final equation? V infinity plus V initial minus V infinity into e raised to power minus t by tau. So V infinity is 30, initial is 15, 15 minus 30 is minus 15, so 30 minus 15 e raised to power minus 0.5 t. So that is our equation of voltage across capacitor. Now in the question they were asking what is the value at t equal to 1 second or 4 second. Nothing complex here, just put t equal to 1 and t equal to 4 and you will get your answers. And as you realize, we said that at t equal to 4 tau or 5 tau, the capacitor will fully charge or discharge. That means it will reach the steady state. What is the value of our tau? 2 seconds. So when I am giving a value which is less than tau or which is 2 times tau, so you can see my final value has to be 30. So we are still far behind. Now for your practice, you just take t equal to 10. That means 5 tau, right? And you will see that this answer will reach almost 30. If you put t equal to infinity in this circuit, you will find answer is 30. If you will put t equal to 0 in this, you will find answer is 15. So all the conditions will match. So friends, this is how we can go ahead with step response of RC circuits. Keep learning. Thank you.